But you can still pick up the net one, but it's really poor in comparison.
Yeah,
so this is it really makes visible these patches of aggregated debris, and you can see how they follow the front so closely. But when we look at the spectral signatures, they're completely different. So it made classifying really easy in this case. And you can, it sort of follows the whole front. And what's really nice about this,
Any plastic that enters the open ocean is inevitably going to degrade into microplastics, or be sunk, or become entangled, or be ingested. We want none of those things to happen. And the idea is that if you can see them before they enter the open ocean, there's something you can do about it. And they're still fresh in the water, and they're within land. They're near enough to land to perhaps do something about it. The other thing that's perhaps useful is we still have a lot of questions about sources, sinks, trends, and pathways. There are a lot of things that we rely on models to answer those questions for. And perhaps when we start to add data on where plastics are accumulating in the coastal zone on the surface of the water, that might help to validate some of the models. That can measure at quite a high spatial resolution. And what I mean by that is it can measure in 10 by 10 meter pixels. For normal marine applications, you don't need such high resolution, but in the coastal zone, it helps you look at things like small boats, river plumes, fronts, all these small features that I find quite fascinating. And it was while I was looking at these small features that I started to notice things that were floating that were also not vegetation.
and it picked up the suspected plastic 90% of the time, and it reclassified some of it as water. As you know, Costa's been putting out the targets, and I've been finding that the floating debris index, I'm picking these up really brightly and really easily, and our classifier is correctly identified. If we get a pixel that is up to 50% filled with netting, we will be able to see it. And I think there are going to be examples in the real world.
Say you've got a 10 by 10 meter pixel. If you've got 30% of that pixel filled with floating material, even if it's mixed material, plant material, as long as it's dominated by plastics, we can start to detect it.
Straight down to the deck. Yeah. Okay, 1, 2, 3. We know already that large items of plastic are harmful to creatures through entanglement and ingestion, and we know that from work out in the ocean. With the microplastics, with the smaller pieces, we know from laboratory studies that there's the potential for those small pieces to cause harm.